All right, so the next thing we are looking at is solving matrix equations. Now, solving a matrix equation is really not that different from solving an equation as you've always done. So for example, this first equation that we're going to look at is very similar to if we had something like x plus 3 equals 6, right? You know how you'd solve this. You would use an inverse operation, so subtract from both sides to get the x by itself. That's exactly what we're going to do to solve this one. Okay, now I have here x plus a matrix. So typically we would then subtract to cancel the addition. What I suggest you do though is instead of subtracting, add the opposite matrix. So see how I just changed the signs on all of those numbers? I'm going to add that matrix to both sides because what I tend to find happens with students is that they'll accidentally forget that they're supposed to be subtracting partway through, and then it messes them up. So those will cancel. 6 plus negative 3 is 3. 3 plus negative 2 is 1. 7 plus negative 1 is 6. Negative 1 plus 0 is negative 1. And there we go. That's the solution to this matrix equation. All right, so then we look at our second matrix here. This one we have a matrix and something has been subtracted from it. So just like you assume we would add then. And this one, I'm doing the opposite operation here. So I want these numbers to stay the same. So I'm going to add negative 9, negative 3, 6, 0 to both sides. So these guys are going to cancel. So your two options are either keep the operations the same and the signs different, or the operations different and the signs the same. Either way will work. So then from here, 4 plus negative 9 is negative 5. 0 plus negative 3 is negative 3. 12 plus 6 is 18. Negative 10 plus 0 is negative 10. And there's our answer. All right, great. So adding and subtracting, not a big deal. This last one here, though, this one is a multiplication matrix, okay? And that is going to make it a little bit trickier because we're going to have to find an inverse. Okay, so this one's going to be a little bit messy along the way, but in the end, it's going to work out to a nice whole number answer, okay? And you should expect that while you're working on your problems. Okay, so in order to do this, we're going to have to first find our inverse matrix. Okay, and now it's important when you're multiplying by a matrix that you make sure you multiply on the correct side. Okay, so in order to get rid of this matrix, I'm going to have to multiply right here, right? I'm going to have to multiply some number times here in order for them to be next to each other. Okay, which means that on this side, when I go to find my answer, I need to also multiply on the left side. Okay, now this is something that's kind of different and new to you because you're used to something called the commutative property. Okay, and the commutative property says that if you do 3 times 2, you get the same answer as if you do 2 times 3. Okay, the answer is the same no matter what you do. Okay, so multiplying 3 times 2 is equal to multiplying 2 times 3. When you're talking about matrices, though, if you're multiplying matrix A times matrix B, you do not get the same answer as if you multiply matrix B times matrix A. It's not commutative. Okay, and that should make sense because think about how our matrix multiplication works, right? Remember how we talked about the dimensions? So I can multiply, say, a 2 by 3 matrix by a 3 by 5 matrix, right? Because these dimensions match. But if I were to turn them around and do a 3 by 5 by a 2 by 3, well, now I can't multiply them because these guys don't match anymore, right? So in one order, it's possible to multiply them, but in the other, it's not possible. Okay, so it matters with a matrix what order you multiply them in because you'll get different answers. Okay, so since on this side, I have to put my matrix on the left because there's already something on the right. Okay, there's always already an x there, so I can't multiply on that side. So I'm multiplying on the left on this side, so I have to make sure I multiply on the left on that side. Okay, so what we're going to do is we're going to start by just finding our inverse matrix. So we are going to find the inverse of this 7, 5, 3, negative 2. Okay, that's my first step. Okay, so I'm going to grab my calculator, right? Go into my matrix menu, so second and then x to the negative 1. These are the matrices that we worked with last time. You can just overwrite them. So I'm going to just go over on matrix A, and I'm just going to go through and redo this one. So it's now going to be 7, 5, 3. Oops. Sorry, that was a 3. I typed negative 3. There we go. So there's my matrix. I'm going to quit out of this. And then I'm going to find the inverse of it. So matrix menu, matrix 1, find the inverse, and I'm going to go ahead and make sure it's in a fraction form at the same time. Great. Like I said, it's going to be a little messy along the way. So my inverse matrix is 2 over 29, 5 over 29, 3 over 29, and then negative 7 over 29. All right, lovely. So now that I have my inverse matrix, now I'm going to solve the equation. Okay, so in order to do this, okay, let's see, I'm going to call this guy A, so that then I can just write that this is a to the negative 1. Okay, so what I need to do to multiply this is I'm multiplying, right? So it's matrix A, right? This is what we have so far. A times X equals this 322. Sorry, no fraction line. Okay, so what I'm going to do here is I'm multiplying by my inverse here, my left-hand inverse. So I have to multiply by it here as well. Okay, so I'm going to multiply my inverse matrix, this guy up here, times this guy in that order. Okay, now conveniently, I already have this inverse in my calculator, right? So I already have my inverse. So what I'm going to do is I'm going to go in and I'm going to enter this little tiny matrix in another spot so that it will do the multiplying for me. Okay, so I'm going to go back to my matrix menu. Now I'm going to edit the second matrix. I don't want to mess with the first one because I'm still using it, right? We're going to use that inverse. So I'm going to change this one. This one is a 2 by 1 matrix, and it was 322. Quit back to my second menu, and you can see your answer still there, right? If you need to, rerun this again so that you get the right answer. And then I'm just going to say multiply that answer by matrix B. And that's what my answer works out to. So it's 4, negative 5. Okay, so I have now that the x, because these guys cancel each other, is going to be 4, negative 5. And that's the solution to this matrix equation. Okay, so adding and subtracting ones aren't bad. The multiplying ones can be a little bit annoying, right? Because we can't divide, right? There's no operation in matrices to divide. That's not a thing. You have to use inverses. Secretly, there's never division. Division's not really a thing. It's always inverses. We just make them a little bit easier, right? But that's what we're doing here is we're figuring out inverses and we're multiplying, and using your calculator can really help you a lot with some of the time-saving stuff.